Hello and welcome back. As promised, today we have our last new topic that I'm going to teach for this unit. It's going to be on the equation of a circle. Now we've saved the best for last. Oh wait, tangents was by far my favorite with all the space math, but this one's pretty dope too. Yes, I just used that word. So I think you're going to like it. I've got some really cool visuals for you on this one, even better than what I had last year. So I'm really excited to show that to you. Get to show off some of the smartboard skills. So what we have here is a section of a circle. This is an arc, and as we notice, the circle here is only in the first quadrant. So we're only dealing with positive coordinates. And in this circle here, one of the things that we have is we have a right triangle here, which is made up of this x component and this y component. And we know that when we take this a squared plus this b squared here, that's going to give us the length of our radius. And the radius is what we're really interested in here. In fact, we're wondering what are the pairs of x's and y's that give us this same distance, this same radius that'll get us to any other point. So for instance, here with 3, what coordinates, what pairs with 3 is going to be the same distance from the center here? Those are the types of questions that we need to answer when we discover what the equation of a circle is. So first thing is that we are dealing with the Pythagorean theorem, or in other words, the distance formula. What set of a's and b's, or x components and y components, give us a distance away from the center that is whatever the said radius is. So if I plug this in with the values we have here, we have an x component of 3 and a y component of 4. So this point here is 3, 4. And the next question I might have is, well, what is that radius or that distance? Well, we can put that in our calculator. It's pretty simple. You probably already know it because it's a Pythagorean triple that we use all the time. But 16 plus 9 is 25. And then to find the radius, we take the square root of 25. Which is going to give us 5. So our radius in this case is 5. Now we want to know what are the other possible points. In this case, we're looking at positive integers, or some pair with a positive integer that will also be 5, a distance of 5 away from the radius. So for that, an obvious one would be this one here. So whenever x is equal to 0, what does the value of y have to be? Well, y would have to be equal to 5, right? Because that would give us the distance of 5. And so what we end up coming up with, and the same thing over here, right? So whenever y is equal to 0, what does x have to be equal to? 5, because 5 and 0 is going to give us 5, right? So this ends up giving us basically from the Pythagorean theorem or the distance formula, the equation for this circle, or at least the positive integer equation of the circle for the arc, right? Because we're only dealing with the first quadrant for now. So we want to know pairs of x's and y's such that when we square them and add them together, we get the radius squared, which is 25. It'll be easier to think of that instead of 5 squared. We'll just think of it as 25 now. So what pairs of numbers that when we square them and we add them together is going to add up to 25? So that's our first question. So if we do, I think our first one here is 0. Yeah, so our first example. So when x is equal to 0, what does y have to be equal to? Well, 0 squared plus something squared is going to give us 25. Well, if this is 0 squared, that's 0, right? So the whole other 5 squared, the 25's got to come from this one, which means that the y pair would have to be 5. So that gives us the ordered pair of 0 and 5. What about the second one? Well, I've kind of given you the answer there. Should have hit it a little bit better. But whenever we have 1, when we square 1, that's going to be 1, right? So that's 1 of the 25. So how do we get to the other 24? Well, we're going to use the square root of 24. So our answer would be 1 squared, which is 1, plus the square root of 24 squared. And what happens when we square the square root of 24? We get just a regular 24, right? So 1 plus 24 is equal to 25. And that's kind of how this game is going to be played. I guess I'll move that one down there. All right, so what about with 2? So 2 squared is 4. So how much is left of our 25? So if we have 2 squared is 4, 25 minus 4 is going to be 21. So this value here would be the square root of 21. See how those pairs, when we square them together, is going to give us 25. All right, what about 3? So we have 3 squared. You might actually notice that we did a pair of 3 and a 4 here. So if one of them is 3, the other one actually have to be 4, right? So that's that. We'll just go off of this here. So what about when 1 is 2? Well, we already said here when 1 was 2, we square it, gets 4. So the other one has to be radical 21. And when one of them is 1 squared is 1, so the other one has to be radical 24. So hopefully that's not too difficult for you to see how all these positive integer pairs, or one of them is a positive integer, would be some of them are paired with a square root, a radical, right? Some of them are perfect squares, which is kind of nice when we get a few of those working in our favor. But that's not all of the points of a circle, right? Because we know that a circle is a set of all possible equidistant points. So it is true that all of these points are a radius of, or a distance of 5 away from the center. So these all have the exact same radius, which is 5 away from the center. But what about all the other points that exist on the line here? So what about all these infinitely many points? Let me change the color so you can actually see it. But the infinitely many points that exist between x's of 3 and 4 that are also equidistant between those two. What are all those points going to look like? So that brings us to our next question, or our next slide. All right, so what do all those other points look like? Okay, so here are some other ones that are graphed out, these red points here that we haven't looked at. And we're going to find out what those are. They're all going to be radicals, radical integers. So I think I showed it here. Yeah, so here's a few of them that are graphed out, kind of color coded here so you can see what's going on. So the first one we have is 0, 5. Then we have 1 radical 24, right? Then there's a few of them that we're missing, these two, right, the pair. And then 2 radical 21, which again, when we square that, 2 squares 4, and 4 plus 21 is going to give us 25, right? So we're looking for pairs of numbers that when we square them and add them together, it gives us 25 from the distance formula. Then we have quite a few that are in between 3 and 4, and then 4 that are between 4, or the y values of 3 and 2, and 4 and 21. Then we continue on. There's a few more over here. Then the last two, there are no in between those two. So how do we find those values? Let me go to the next slide here. So this might look a little intimidating, but once you get the pattern, it's actually really, really cool. I'm kind of excited because I get to show you this awesome visual. So remember, when we're squaring these, they're going to add up to 25. So 0 squared and 5 squared is 25, right? 1 squared and radical 24 squared is going to be 25. So what happens when we square radical 2? Well, it becomes a regular 2. And what pairs with a regular 2 to get it up to 25? So before we square it, that would be a radical 23. And you should start seeing the pattern here. Oops, I didn't lock that one in place. I'll fix that real quick. All right, so that would be radical 23. So what would pair with radical 3? Okay, so that's going to be radical 22, okay? And then 2 is a perfect square, right? So that would be 4 goes with the 21, right? What does radical 5 go with? Radical 20, okay? So you're hopefully seeing the pattern here. We're adding these two together when we square them, and they're going to give us 25. So what does 6 go with? So that would be radical 19, and then radical 18, radical 17. See the pattern? It's actually pretty simple. Then we have radical 15, radical 14, radical 13. Really need to fix that. Then the same thing happens here. So what pairs with 13 that gives us 25? So it'd be 12, and then we have 11, and then 10, and then radical 9. But radical 9 is the same thing as 3, right? So we can reduce that as an integer. Radical 8, 7, 6, 5, 4, 3, 2, 1, 0. You get it. Awesome. So that's it. Not really that bad. I know this looks like a crazy mess of points, and that's actually what I graphed and plotted out here. A lot of work, but once you do it once, you don't ever have to do it again, so it's worth it. So all those points in between those integer solutions, or at least one integer, are all these other radical integer solutions, which is pretty stinking cool. And they're all basically based off the Pythagorean theorem, where some radical length here. So radical 10 and radical 15 is going to be one of those points, which would be this one right here, right? No, radical 10 is actually just a little bit bigger than 3. So radical 10, radical 15 is going to be this point right there. Then this would be radical 11, radical 14, radical 12, radical 13, radical 13, radical 12. And that's kind of the turning point between those two, by the way. So anyway, it might seem like black magic how I can do all that stuff, but it's actually pretty cool and pretty simple. So by the way, we've only been working with an arc. That's the first quadrant, so the first part of the circle. But what if we look at, this is awesome. the entire circle, which is all 4 quadrants. So if we take all these points, which we just looked at where those came from, right? And if we took all those and we reflected them across the y-axis, now instead of xy, they're negative xy. So this point here, 4, 3, that one could be the same thing as negative 4, 3, right? And isn't that going to have the same component over here, the same x component, the same right triangle? Well, sure, and it's going to have a radius of 5, right? And the reason for that is that whenever we square a negative, what happens? Well, it becomes positive, so it doesn't matter that it was a negative. So first we have 4 and 3, which gives us 25, right? 16 and 9. The next example would be negative 4 and positive 3, which is still, when we square a negative, is positive 16 and 9, which is 25. So what about in this quadrant here? I guess we'll do this one. Well, reflected across the x-axis. So now we have 4 and negative 3. It's still the exact same right triangle that we were dealing with here. So it's going to have the same radius length here, which is also still going to be 25, right? Or r5 squared is going to be 25. And the last one's when we make both of them negative, which, as you can guess, of course, is also still going to be the same radius of 5, and when we square that radius, it's going to give us 25. So this is so far the equation of a circle, at least the equation of a circle that's centered at the origin. We're just going to kind of take it one step at a time, and hopefully you can see where those are coming from. But remember, we just moved one of these points, but every single one of these points here, all 25 of them, can be moved and reflected across the x-axis, the y-axis, or both, or rotated 180 degrees. So I'll show you that real quick. I know, this is so dope. Yeah, I used that word twice now. It's all Gucci, don't worry about it. So on this one here, notice that these x values now became negative, and it's the same points here, just reflected across the y-axis. Then on the second one here, I'm going to show you, we have all of these are reflected across the x-axis. Now the y values are becoming negative. So rad 24 and 1 is now rad 24 and negative 1. And then the same thing, you don't want to know how long this took me to put together. It's ridiculous, but it's worth it. You're worth it. All right, so number 3, we do negative x and negative y. And all these values have now been changed to negative values. So you can see how all 25 of those points are plotted in all 4 quadrants. So there's 100 points that are plotted right there. Now, I don't expect you guys to plot 100 points, but if you did have these 100 points plotted, I bet you could connect the dots and draw pretty rough your circle that doesn't look like a tomato, like the last one that I tried to do freehand. All right, so the next question we have is, what about the equation of a circle that's not centered at the origin? And most of the ones we're dealing with won't be centered at the origin, so it's going to change our formula a little bit. So first, let's talk about the roots. So if you remember back in Algebra 1, a whole year ago, the roots of a function, or roots of a problem, an equation, are going to be when it crosses the x-axis. So those are called the roots. Now on this circle here, we have x squared plus y squared is going to be 1 squared because our radius is 1, right? So we could rewrite that as just x squared plus y squared is equal to, and I'll just write 1 here if it'll let me. I don't know if it's locked in. Nope, I just can't double tap with the other one. All right, so what is one of those roots? Well, the roots are when the y values are 0. So when y is 0, that means it has no rise component to it. So our 2 roots are going to be where it crosses the x-axis, which is going to be at -1 and at +1, right? Now, how do we show that or prove it? Excuse me. Whenever y is equal to 0, then we're just simply left with 0 squared, which is 0, when additive identity. When we add it, add 0 to anything, it stays the same, right? So x squared is equal to, we'll just call that 1. So then the question is, what does x have to be equal to? Well, how do we undo a square? We take the square root. If we take the square root of one side, we have to do it to the other side, right? So this is a square root and this is a square root. And so we have x is equal to 2 possible values. And it's not just +1, but if you remember, it's plus or minus 1. When we take the square root of something, it's actually our solutions are the positive and the negative values. Now, most of the time in geometry, we don't worry about the negative values because we don't have negative distances. But in this case, we do need to point it out. So our 2 solutions are x could be -1, x could also be +1. Oops, I grabbed the wrong thing. So +1 and -1. So the next question I have is, what happens when we shift this off of the origin? So what about now when it's centered at the point 1? Well, what are the two roots now? 0 and 2. Okay, so how does that affect our formula in our equation? So I'm going to shift this off of the center here. So now, I suppose I probably should have hid this, but on this one, the equation is now going to be x minus 1 squared plus y squared is equal to 1, which is the radius squared. So you might be able to catch on to what we did, but just to prove that that is the equation for the red one, where the parent graph would be the black one, where the parent graph would be the red one. Let me prove that to you. So y is going to be 0. We're finding the roots, which have two solutions of 0 and 2. So when we add 0, we just get the same thing. It's the additive identity. So we have x minus 1 squared is equal to 1. So we take the square root of both sides. And my question is, what two values for x will be solutions for this problem? So I want it to be equal to 1, and I want to square it. Now, before foiling this out and squaring it and dealing with polynomial, don't want to mess with any of that stuff. Just what values could you plug in for x to get 1? Well, if we plugged in 1, we would have 1 minus 1, which is 0, right? And 0 squared is 0, not 1, so that wouldn't work. Let's try another one. In fact, look at your graph. Which two values should it be? 0 and 2. So let's see if one of those, yeah, it is 0. All right, so what is 0 minus 1? Negative 1, okay? Negative 1 squared becomes positive 1. So that is one of our solutions. And what's the other root, which we can graphically see over here, has to be 2, right? So what is 2 minus 1? Positive 1. Positive 1 squared is, of course, 1. So that is going to be our two solutions. So what changed? Well, when we took this graph here, the circle, from x squared plus y squared is equal to 1, and then I moved it over to the right one, how did that change our equation? Well, our equation, let me change this to red so you can kind of pair those up. So our equation went from x squared plus y squared is equal to 1 to x minus 1 is squared plus y squared is equal to 1 for the black one here. So what's changing? We went from x squared to x minus 1 squared. And what we did is we went from the origin of 0, 0 for the center of the circle to the point 1, 0. So what's happening here is this new modified formula. This is the actual like full formula for the circle when we don't have a special case of going through the origin, which is rare that ever happens. And it goes like this. So x minus h squared plus y minus k squared is equal to r squared, where h and k is the center. Now, why they choose h and k? They're just two letters that are paired next to each other in the alphabet, and they weren't being used for any other parameters, so those are the two that we picked. I don't know why anything other than that explanation for why they're paired together. So anyway, h and k, where h is the x component of the origin, which would be 1 in this case, and that's why it was x minus 1, if we notice that. So that would be, this is the 1. And then the k, it's still origin, or at least at 0 for the y component, so it would be y minus 0, which is why it just stayed as y squared. All right, so that's our equation for the circle. That's going to be written on your assignment. You're not necessarily needing to memorize that anytime soon, but well, scratch that. You should memorize it eventually, but I'll put it on the assignment for you so you don't have to keep referencing back to the video. All right, so we still want to be able to find the midpoint. So if I give you two endpoints of a diameter, one of the things I need you to do is be able to find the center of that circle, which we can actually pretty well locate just by visually looking at that. But sometimes it won't be so clear what that value is. So the midpoint formula, again, if we remember, is the average x and the average y. So we're going to take our x components, which is -1 and -5, add them together, which is -6. Half of that is -3. And of course, that's the average -3. Then take our y values of 0 and -4, add them together, -4. Half of that is -2, which of course is the component here. So that's going to be the center of our circle. It's going to be at -3, -2. Now we're going to plug in those values for the center for the h and the k. So -3 and -2. I guess I'll write that down. So we have here -3 and -2, and that's our center. So we're going to plug in those values for h and k, -3 and -2, into the equation for our circle. So when we do that, we're going to end up with x minus a -3 squared plus y minus a -2 squared is all going to be equal to the radius squared. So I still need to find out what is the radius of this circle. So to do that, I can go from the center and find a right triangle to do the Pythagorean theorem. Actually, let me cheat on this one just a little quick. There we go. So I can draw my straight lines. So, because, struggle with straight lines. What were you thinking? All right, so going from the center to the endpoint of one of the diameters, and we do have a right triangle here, of course. Oh, this is so much easier than drawing this by hand. All right, so we still have a right triangle there. How am I going to find out what that distance is for the radius? All right, we just do the Pythagorean theorem, right? So we're going to do 2 squared plus 2 squared, which is 4 and 4 is 8. So the radius is going to be radical 8. So when I have radical 8 and I square it, it's just going to become a regular 8. So in our equation, we're just simply going to write is equal to 8 because it's going to be the radius squared, which is 8. And that's kind of nice. That way we won't have to deal with any radicals here. Because when we square a radical, it's going to become an integer anyway, or a whole number. All right, so on this one, what happens when we subtract a negative? Well, it becomes plus a positive, and this also becomes plus a positive. So when we write the actual equation, it's going to look more like this. So x plus 3 squared plus y plus 2 squared is all going to be equal to 8. And that's going to be the equation for this circle. That's pretty much it. So I think we're almost done here. Oops, going back. Yep, that's it. So 20 minutes in. It took a little longer than I thought. Tomorrow will be a lot quicker because we're just going to repeat that pretty quick. And then we'll go right into the assignment. So we'll have 2 days to work the assignments on these because I know they're a little bit trickier. If you need to re-reference the explanation for tomorrow or today, you can always go back and watch the video again. So if you'll get out your assignments, and I'm sure you guys saw the change in the policy, so I am going to have you guys turn in the assignment. So let's make sure that we are doing these. You got lots of options, and I know you guys are used to using Google Classroom in your other coursework, especially in your science classes, and so you know how to submit those assignments. I'm sure you can get that figured out. So good for you guys for doing that, and thank you to all of you who were doing your assignments before anyway. You just weren't turning them in, so there's really no new thing here. But yeah, so moving on, let's do number 1 and 2. So number 1 wants us to identify the center and the radius. They give us the equation of the circle. We want to find the center and the radius. So on this one, remember the values here are going to be your h and your k. But from the equation of the circle, it's x minus h and y minus k. So what value would h have to be so that when we subtract it, it becomes a positive 5? So this might be a little counterintuitive, but it's actually going to have to be a negative 5. So when we subtract a negative 5, remember subtracting a negative becomes a positive 5. So when you're doing these problems, it's just going to be the opposite of whatever sign you see here. So if it's plus 5 and plus 16, your answer is going to be negative 5 and negative 16. So it's just opposite of what you think it would be. Why is it tricky like that? Well, we can go back to the original problem and find out why this is minus h and minus k instead of plus h and plus k, which is what you would think it would be, but it's not. All right, then the only other thing we have to do is find the radius. Well, in the equation, whatever it's equal to is the radius squared. So in order to find the radius itself, so r squared is 1, all we have to do is take the square root of that value. So if this is 1, the square root of 1 is simply going to be 1. So all we have to do is take the square root of whatever that is, which is 1. All right, number 2. Look at these two values here and take the opposite sign of them. So our h in this case is going to be a negative 13, and our k is going to be a negative 1. And then we take the square root of this value, which is 25. Square root of 25 is going to be 5. So remember, this is the r squared, not r. So to find the radius, we simply take the square root of it, and the square root of 25 is 5. And your solutions are on the side. You can cross those out as you go. All right, let's look at number 7 and number 8. So on this one, we want to write the equation of the circle. So we're working backwards. I give you the center and the radius, and I want you to write the equation of the circle. So plug in the value for the center and for the h and the k, and plug in the value for the radius and square it for what the h and the k, or what this part of the equation is equal to, right? So we're going to do x minus, our h is 1, so x minus 1 squared plus y minus our k, which is minus 1 again, squared, is equal to the radius squared. So the radius squared is going to be 13 squared. You can plug that in the calculator, but it's 169. And that'll be the equation of this circle, and that'll be on your answer bank as well. All right, number 8. So now it's centered at 0 and -9. Well, when we do x minus 0, I'll move it up here if I can. Yeah, I'll just put it there. So x minus 0 squared, that's the same thing as just doing x squared. So I'll show that in a second. And then y minus a -9 is going to become plus 9. So I'll move it up there. And then for the radius is 1, so we do 1 squared, which will be just equal to 1. Now on this problem here, we can simplify this down because when we subtract 0 from anything, it stays the same. So that's just going to be x squared plus y minus or y plus 9 squared is equal to 1. And that's how the equation of the circle is going to go when we're looking at this on the answer bank. All right, so look at number 13. I believe this is 13. Yeah, 13. So they tell us the ends of the diameter are 5 and -10. So you might want a ruler on this one. So 5, -10, and 5, 4. So we can graph that out. We go over 5 and up 4 and over 5 and down 10. So those are the ends of the diameter. First thing we want to do, because we're going to write the equation of circles, we need to find out what is the radius and what is the center. So the best thing to do first would be to find the center. Now you can probably guess where the center is. I'm guessing it's about right there. And I wonder if I got that right. But how do we find the center given two endpoints of diameter? Well, just like we did yesterday, we have to use the midpoint formula. So this is going to give us a radius on both sides, which is the midpoint of this line. So the midpoint is the average, right? So if I go from 4 to -10, I add them together, which is -6. Half of -6 is -3. And the average of 5 and 5, of course, is still 5. So our center point is going to be 5 and -3. Now the radius, at this point, we could do the Pythagorean theorem, but it's also the same thing. We could just count it because it's on one of the axes and it's just a vertical line. So our x change is 0, but our y change is going up 1, 2, 3, 4, 5, 6, 7. Or if we go from -3 to +4, what's the distance? Well, 4 to 0 is 4, and 0 to -3 is another 3, so 3 and 4 is 7. So that would give us a radius of 7. Now we would be able to write the equation of the circle, which I don't think I put. So I'm just going to copy and paste this because that's how I roll. All right, so it's going to be x minus our 5, so x minus 5 squared plus y minus a -10, which is going to become plus 10 because when we subtract a negative, that's that. And then 7 squared is going to be 49. And so that would give us the equation of this circle. All right, last one I'm going to do with you is number 15. So we're on the back side here. We just have, 6 problems to do on there. And notice there's no answer bank, but that's okay. You can still do the problems. You should know how to do them. So they want us to identify the center and the radius of each and then sketch the graph. So for this one, to find the radius, remember this is the r squared, looking at our formula. So we take the square root of 49, which is just simply going to be 7, just like the last problem we just did. And to find the center, that's the h and the k. So it's going to be the opposite sign of whatever they show. So in this case, it would be a +2 and a +2. So our center is at 2, 2 with a radius of 7. Now when we want to graph that out, we're going to center it at 2, 2 with a radius of 7. So hopefully I have duplicates. I don't, so I will duplicate one. I'm going to change the color real quick so that we can differentiate the points. But we're going to graph out the points and then we can try drawing the circle. I'm going to use my compass because that's how I roll. Just put a bunch of them over there. All right, so on this one, we want to find a radius of 7. So the easy way would be just to count to the right 7. So if I'm going from 2, over 7 is going to be 9. Okay, conveniently fits where that gets cut off. And then on the other side, I'm going to go over 7 again. So that's going to go to -5. So that'll be this point right here. All right, those have a radius of 7, right? And I could also go up 7 and I can go down 7, which will make this fairly simple. Move that out of the way. So up 7 from 2 is going to be 9 again, and then down 7 from 2 is going to be to the coordinate -5, so 2, -5. All right, now that I have those points, there's really no other integer solutions that we could graph very easily, so you can try to draw a circle. And just to make you guys feel better about yourselves, I'm going to draw this circle, and it's going to be epic. Are you ready? Oh my goodness, that's like not half bad. What is this, Mr. Murphy? You can't draw a straight line, but a curved surface, you are just magically able to do that. I know. Don't look into it too much. It'll just drive you crazy. All right, so how, I'm sure yours look great too. And I'm also doing this digitally. I didn't do it with a mouse. I'm using a writing pad, but still you get the idea. All right, so if we go over here, bet you wish you had a compass. That's what I thought. So anyway, we can draw our circle. That didn't work. Am I going all the way around? If your sketch looks rough, I don't really care. But I do want you to know how to plot the points based on whatever our radius squared is and be able to figure out how to do that. So try that out. You just got 6 problems to do on the bottom there, and I look forward to seeing you guys turn in the assignments and of course, looking at your drawings. So yeah, things will be good going forward. I hope you guys have a good day. The plan is we're going to spend another day doing this tomorrow, so we'll go over things briefly. It'll be a shorter video. Sorry, this one's going about 30 minutes long. And then we will take a practice test on Thursday, and then I will upload a video with the solutions to the practice test so that you can see which ones you missed and why you missed them. And if there are problems that a lot of you guys are missing, I'll go over them, and I'll post that video separate so that we can kind of get our remediation in. So even though we're not meeting and we're not taking any tests, I'm not going to give you a test. It'll just be a practice test. We can still do our remediation and make sure we know this content. And again, we're doing the right thing even when no one's watching. I'm not there to make sure you're not on your phones, make sure you're watching the videos. And up to this point, I wasn't having you turn in the assignments either. So it was kind of all on you, honesty, policies type stuff. So we're still not going to have any grades going in, but I can use this data to possibly raise some of your grades, which most of you guys don't need that. But if you guys are doing all of your assignments and you do well on the test, we can look into possibly raising your grades, which I'm sure you'll be interested in that. So anyway, I've talked enough. I'll let you guys go. So have a good day.